Far below the surface of our planet, hidden within rock layers older than humanity itself, scientists have uncovered mysteries that defy explanation. Microscopic spheres of rare metals, carbon isotopes that don't belong, traces of chemicals that resemble the byproducts of industry, yet date back millions of years before humans ever walked the Earth. What if we are not the first civilization to rise on this planet? What if long before the pyramids, long before the dinosaurs, even before mammals took their place on the evolutionary stage, Earth was home to another intelligence? A species capable of shaping the world, building technology, and leaving behind fingerprints that still whisper through time? This is the Silurian Hypothesis, the daring scientific question of whether an industrial civilization could have existed long before humans, and if so, what evidence would it leave behind? Like and subscribe as we start this incredible journey. We humans like to imagine ourselves as the pinnacle of creation. Unique, special, the first. When we look at our world, the shining skyscrapers of our cities, the satellites circling silently above the Earth, the deep-sea cables connecting continents, we feel a kind of pride. Surely, no one before us could have achieved such wonders. Surely, we are the first to take this planet and bend it to our will. But the Earth itself tells a different story. Our planet is unimaginably old, 4.5 billion years old. To say that number is one thing, to really grasp it is another. The human brain struggles with scales of time so immense that millions of years feel almost the same as billions. We can say the words, but can we feel their weight? So let's try an experiment. Imagine taking all of Earth's history, every volcanic eruption, every creature that ever swam, every tree that ever grew, and compressing it into a single calendar year. January 1st would be the birth of the Earth, when dust and rock in the young solar system came together to form this blue sphere. On that calendar, life itself, simple, microscopic, fragile, wouldn't appear until March. Complex cells with nuclei arrive around September. In late November, the oceans fill with creatures we'd recognize as animals. Dinosaurs stride into the picture in December, ruling the world for more than 3 glorious weeks. And then, in the final hours of New Year's Eve, mammals begin to rise, flowers bloom, and the Earth becomes a place vaguely familiar. Modern humans, we appear at 20 minutes to midnight on December 31st. All of recorded history, from the pharaohs to the pyramids, from Caesar to Shakespeare, from Galileo to moon landings, unfolds in the final seconds before the clock strikes 12. That is how tiny our place really is. A flicker of fire in a dark, endless night. And here's the unsettling thought. If another advanced civilization had risen and fallen, not in the last few thousand years but 50 million years ago, or 100 million, or even 300 million years ago, would we even know? To answer that, let's do something uncomfortable. Let's imagine a future where we are gone. Imagine that tomorrow humanity disappears. Not with a bang, not with a world-ending war, but simply gone. What happens to the traces of our world then? In a decade, nature begins to claw back what was hers. Vines wrap around forgotten houses. Animals creep through the empty streets. Wolves stalk the highways. Birds nest inside broken windows. In 100 years, almost every building collapses. Roofs cave in. Glass shatters. Bridges tumble. The skeletons of our cities stand briefly, then fall. 1,000 years later, even the strongest monuments are crumbling. The Eiffel Tower has rusted away. The Statue of Liberty lies broken in the harbor. The tallest skyscrapers have collapsed into piles of rubble. Only a handful of stone giants remain. The pyramids of Giza, the Great Wall of China, Mount Rushmore. But even these are eroded, battered shadows of their former glory. Leap forward 100,000 years, and entire ice ages have swept across the continents. Glaciers grind the surface like sandpaper, scraping away roads and burying whole cities under mountains of ice. Forests rise, burn, and rise again. Deserts shift, burying the traces of human life beneath dunes. 10 million years later, mountain ranges have risen and been ground down to dust. Rivers have carved new paths, swallowing valleys whole. Volcanoes have spilled lava across ancient landscapes. Oceans have risen and swallowed coastlines, only to retreat again. What chance does a city have against such relentless forces? Practically none. Geology is the great eraser. It is patient, merciless, and thorough. So then, what of us? What of our story? What would remain for some far future intelligence to find? Not our monuments, not our cities, not the great machines of industry. What would remain are fingerprints, faint but telling. A thin line in the rocks, a chemical scar. Traces of carbon from our burning of fossil fuels. Plastic particles, transformed by pressure into strange new rock-like substances. Unnatural isotopes, the ghostly reminder of our nuclear experiments. Perhaps a fossil here or there, one human skeleton, a cow, a dog, if they were lucky enough to be buried in just the right conditions. And that's all. Billions of lives, entire empires, countless triumphs and tragedies, all reduced to a layer of dust and chemical residue, a whisper in the stone. And if this is true for us, if we, with our global cities and world-spanning technologies, could disappear so completely, then we are forced to ask a question that chills the blood. What if it has happened before? What if another species, not human but something entirely different, rose to intelligence long before us? What if they, too, built their world, discovered energy, created technology, only to vanish into silence? Would we recognize the signs? Or would we dismiss their fingerprints as natural quirks, just as we almost dismissed our own warming climate as a simple cycle of the Earth? This thought is not as far-fetched as it seems. Consider the dinosaurs. They ruled the Earth for more than 160 million years. That's over 800 times longer than humans have existed. And yet, what remains of them? Bones, teeth, footprints pressed into stone, a few chemical traces. That is all. If hidden somewhere in that immense span of time, an intelligent branch of dinosaurs had risen to build cities, what would we see of them 65 million years later? Almost nothing. Perhaps not even enough to prove they were real. Absence of evidence is not evidence of absence. That phrase has become a cliché, but here it may be the most important truth of all. Just because we have not yet found proof of another civilization does not mean there was none. It means only that the Earth is a poor archivist. Its records are scattered, its memory fragmented, its history rewritten again and again by fire and ice and time. This is the humbling realization at the heart of the Silurian Hypothesis. Our story may not be the first. We may only be the most recent chapter in a saga that has played out again and again, civilizations rising and vanishing beneath the shifting skin of stone and time. And as outlandish as this may sound, it is not simply a tale for science fiction. It is a serious scientific thought experiment, one that forces us to rethink what civilization means, how fragile evidence really is, and whether Earth itself might be hiding secrets older than humanity. And so we must ask the question that will guide us through this journey. If we are not the first, what traces should we look for? What clues could survive? And more importantly, Are there already hints waiting in the rocks beneath our feet? The Silurian hypothesis begins, strangely enough, not in the fossil beds of a desert or the core samples of an ocean trench, but in the minds of two scientists who dared to ask a question most would laugh at. In 2018, astrophysicist Adam Frank and climate scientist Gavin Schmidt published a paper in the International Journal of Astrobiology. At first glance, the title seems straightforward: the Silurian Hypothesis. Would it be possible to detect an industrial civilization in the geological record? But hidden within those words was a question bold enough to rattle the way we see ourselves. They weren't claiming there was an ancient civilization. They weren't saying dinosaurs built cities or that some forgotten species once had technology. What they asked was far more subtle and in many ways more disturbing. If such a civilization had existed millions of years ago, how would we know? That single question flips the burden of proof. Normally, scientists dismiss wild claims with the phrase, "Extraordinary claims require extraordinary evidence." But Frank and Schmidt turned it around. If evidence is so fragile, what if even an extraordinary civilization could vanish without leaving a trace? The very name of the hypothesis carried a wink and a nod. They called it Silurian, after a species in the long-running science fiction series Doctor Who. In that story, the Silurians are an ancient reptilian race who thrived long before humans, retreating underground to hibernate while mammals took over the Earth. When they awaken millions of years later, they find themselves face to face with us, the newcomers. Frank and Schmidt weren't claiming reptilian overlords were real, but the metaphor was perfect. Science fiction had already played with the idea of civilizations before our own. What they did was strip away the fantasy and treat the question with sober seriousness. And the more they looked at it, the more troubling the answer became. First, the idea sounds absurd. If there had been an industrial civilization millions of years ago, surely we'd have found ruins, tools, bones, or fossils. Surely something would remain. But science is about testing assumptions, and when you test this one, it begins to crack. Frank and Schmidt argued that when we look at Earth's geological record, it is full of gaps. Whole continents worth of rock have been ground down and subducted into the mantle. Oceans are constantly recycling their crust, erasing millions of years at a time. Fossils are incredibly rare. Only a vanishing fraction of life ever makes it into stone. And the more time passes, the rarer that preservation becomes. So the real question is not, would we have found ruins? But what kind of evidence could possibly survive tens of millions of years? And their answer was sobering: very little. Almost everything we think of as civilization, buildings, machines, even bones, would be gone. What might remain are the indirect signatures, the fingerprints of industry, strange isotope ratios in the soil, carbon anomalies in the atmosphere, layers of unusual materials like plastics or synthetic compounds. Perhaps, in the rarest cases, a fossilized artifact preserved under perfect conditions. But mostly, what we'd be left with are the kinds of signals we're creating right now. A sudden, sharp chemical shift in the planet's surface, detectable millions of years later by some future intelligence digging into the rock. To illustrate their point, Frank and Schmidt proposed a reversal of perspective. Imagine, they said, that an alien scientist came to Earth 100 million years in the future. What would they find of us? Would they see the outlines of cities? No. Would they find intact machines? Not a chance. Would they dig up human bones by the millions? Almost certainly not. But what they would notice is that at a certain point in the rock layers, the carbon cycle of the planet shifted abruptly. They would see traces of fossil fuel burning, massive climate warming, and extinctions clustering together. They might find rare isotopes left behind from nuclear weapons. They might even stumble across compressed layers of plastic, transformed into a kind of technofossil stone. To that alien scientist, it would look as though some brief but intense industrial phase had occurred, an industrial spike that lasted maybe a few centuries or millennia, followed by collapse. Now, turn the thought experiment around. If we saw such a spike in Earth's past, would we immediately think, "Ah, an ancient civilization?" Or would we search for natural explanations, volcanoes, asteroid impacts, methane releases? Frank and Schmidt believed the latter, and that is precisely the problem. Even if we did stumble on a geological scar left by another species' industry, we might never recognize it for what it was. It's easy to laugh at the idea of lost civilizations. After all, human history has its share of conspiracy theories: Atlantis, ancient aliens, supposed out-of-place artifacts that claim to rewrite prehistory. Serious scientists avoid these subjects, not wanting to be lumped in with pseudoscience. But the Silurian hypothesis is different. It doesn't start with fringe claims. It doesn't start with a supposed artifact or mystery ruins. It starts with a serious scientific puzzle. How much of our own civilization would survive in the deep geological record? By framing the question this way, Frank and Schmidt weren't endorsing wild claims. They were creating a thought experiment, a lens through which to view both our own impact and the limitations of geology. And perhaps most unsettling of all, their conclusion was that it would be very, very hard to rule out the possibility of civilizations before us. To understand why this resonates, look not at deep time, but at our own shallow history. Human civilization is only a few thousand years old, and yet we have already lost whole chapters of it. Think of the Indus Valley Civilization, once one of the great powers of the ancient world. With cities, plumbing, and a written script, it flourished for centuries, then collapsed. Today, most people barely know it existed, and much of its language remains undeciphered. Or take the Maya. At their height, they built monumental cities in the jungles of Central America. When their civilization declined, the rainforest swallowed their temples so completely that Europeans arriving centuries later had no idea they were there. Even closer to our time, consider the Library of Alexandria, a treasure trove of ancient knowledge, lost in fire. Entire books, philosophies, sciences, gone forever, their contents unknown to us. These are losses across centuries and millennia. If civilizations can vanish almost without a trace in a few thousand years, how much harder would it be to detect one from 100 million years ago? Some might wonder, why name it after a fictional species? Isn't that unscientific? In fact, the choice was deliberate. By using a name from science fiction, Frank and Schmidt acknowledged the strangeness of the idea while disarming critics. It was a way of saying, we know this sounds wild, but let's treat it with rigor anyway. And that balance between playful imagination and serious inquiry is what makes the hypothesis so powerful. It forces us to confront uncomfortable truths, not just about the possibility of ancient civilizations, but about the fragility of our own. The real brilliance of the Silurian hypothesis is not in whether it proves another civilization existed. It's that it opens the door to deeper questions. How do we define civilization? Is it skyscrapers and satellites? Or is it the chemical imprint we leave behind? How long does intelligence last on a planet before it consumes itself? Could other worlds we explore, Mars, Venus, even exoplanets, bear similar signatures of civilizations that came and went? By asking whether we could detect one here, Frank and Schmidt created a framework for looking everywhere. And perhaps, hidden in that framework, is a quiet warning. If the only thing left of us millions of years from now is a thin scar of carbon, plastic, and radioactive dust, then maybe that is the fate of civilizations everywhere. Brief, brilliant, and fleeting, the Silurian hypothesis began as a playful nod to science fiction. But beneath that playful exterior is a deeply serious question, one that challenges our assumptions about time, about evidence, and about the uniqueness of humanity. If we could vanish without a trace, then maybe, just maybe, someone else already has. To understand why the Silurian hypothesis carries weight, we first need to confront the scale of geological time. It is the vast canvas upon which Earth's story has been painted, a canvas so immense that even the entirety of human civilization barely registers as a brushstroke. Most people think in centuries. Some can stretch their imagination to thousands of years, back to the pyramids or the earliest recorded history. A few might reach tens of thousands, imagining the last ice age or the cave painters of Europe. But to grasp geological time, we must think not in thousands, but in millions and billions. The Earth is 4.5 billion years old. Over that staggering expanse, continents have drifted, oceans have opened and closed, mountains have risen and crumbled, climates have swung from frozen snowball states to sweltering greenhouse hothouses. Life itself has gone through repeated revolutions, flourishing, collapsing, and reinventing itself anew. Against this backdrop, modern humanity, cities, science, technology, has existed for less than 10,000 years. A fraction so small that, if Earth's history were compressed into a single calendar year, all of recorded civilization would occur in the final 30 seconds before midnight on December 31st. That perspective is humbling, but it is also dangerous because it blinds us to the depths of time where secrets could be hidden. Let us imagine for a moment that we buried a city today, New York, Tokyo, or London, under tons of rock and sediment. What would remain in 10 million years? In the short term, skyscrapers would collapse. Steel would corrode, concrete would crumble, glass would shatter. Within a few centuries, nature would reclaim everything. Forests, rivers, and soil would erase the surface, covering the ruins in layers of sediment. Within a few million years, tectonic pressures would compress those layers into stone, scattering fragments of human construction like pebbles lost in a gravel bed. By the time 10 million years had passed, the surface evidence would be almost entirely gone. Only in rare conditions, such as rapid burial by volcanic ash or preservation in an anoxic seabed, would fragments survive as fossils of technology. And even then, the odds of them being uncovered in the far future would be vanishingly small. Now extend this thought experiment. What about 100 million years? By then, the continents would have shifted, mountain ranges would have eroded away, and ocean floors would have been recycled into the mantle. Almost no surface trace of our civilization would remain. If that sounds unbelievable, consider this. We live on a planet that has been home to countless empires of life before us, and yet their traces are often astonishingly faint. Dinosaurs ruled the Earth for 165 million years, over 16,000 times longer than recorded human civilization has lasted. And yet, what remains of them? A scattering of fossils, some footprints, a few impressions of skin and feathers. Out of the billions upon billions of dinosaurs that lived, only a tiny fraction ever fossilized. Most vanished without a trace, their bones eroded, their bodies consumed, their existence erased. For all their dominance, for all their immense time span, the story we reconstruct of them is based on scraps, whispers preserved by chance. If creatures as vast, numerous, and long-lived as the dinosaurs left so little, what chance would a short-lived technological species have? The fossil record is biased toward the rare and the lucky. Hard shells fossilize better than soft bodies. Creatures near riverbeds, lakes, or deltas fossilize more often than those on open plains. Entire ecosystems can vanish without leaving behind a single fossil, as if they never existed at all. This is why paleontology is a science of fragments, of puzzles with missing pieces. The deeper we go in time, the more pieces are missing. Geological time is not a perfect archive. It is more like a palimpsest, a manuscript that has been written, erased, and overwritten countless times. Sediments build up, only to be lifted and eroded away. Rock layers are folded, faulted, melted, or subducted. The surface of the Earth is constantly rewritten. This means that even dramatic events, mass extinctions, asteroid impacts, supervolcanoes, often leave subtle signatures. The asteroid that ended the Cretaceous period 66 million years ago, wiping out most dinosaurs, left only a thin layer of iridium-rich clay, visible in scattered locations around the globe. Without that layer, without a few shocked minerals and a buried crater in Mexico, we might never have known it happened. Now imagine trying to detect something subtler, like a brief industrial civilization that lasted only a few tens of thousands of years. Against the backdrop of hundreds of millions, it would be no more than a geological heartbeat. Its signals could be faint, localized, or erased altogether. Another difficulty is how deep time compresses events. When we look at a rock core, we might see a few centimeters of sediment representing thousands of years. In older strata, a few centimeters might represent hundreds of thousands or even millions. Events that felt long and dramatic to the beings living them can appear as razor-thin layers to us. For example, the Paleocene-Eocene thermal maximum, a sudden warming event 56 million years ago, lasted around 200,000 years. To humans, that would be unimaginably long. Yet in the rock record, it appears as a narrow band of chemical shifts, one that could easily be overlooked without careful study. If an industrial civilization had existed then, its entire rise and fall could be compressed into that same band, indistinguishable from natural climate variation. Unless we knew what to look for, we might never suspect it was anything but geology at work. There is also the matter of our own perception. Humans are not wired to think in deep time. We evolved to survive days, seasons, maybe decades. The lifespan of a tree can already feel eternal to us, let alone the lifespan of a mountain or a continent. When scientists describe millions of years, we nod our heads, but we rarely internalize what that truly means. We treat 1,000,000 years ago and 100 million years ago almost as if they were the same, just a long time. But in reality, the difference is staggering. 1,000,000 years ago, early humans already roamed the earth. 100 million years ago, our ancestors were tiny mammals scurrying in the shadows of dinosaurs. This flattening of time in our imagination makes it easy to dismiss the possibility of hidden histories. If we struggle to grasp the sheer scale, we underestimate how easily civilizations, even powerful ones, could be buried and forgotten. Here lies the paradox. On one hand, human civilization feels so overwhelming, so permanent. Our cities, satellites, and industries seem impossible to erase. On the other hand, when viewed through the lens of geological time, we are fragile, fleeting, and almost invisible. Both are true. In the short term, our impact is colossal. In the long term, the Earth is merciless in its ability to erase. This paradox is at the heart of the Silurian Hypothesis. It reminds us that what feels eternal to us is temporary to the planet, that our records, our monuments, our very bones could vanish, leaving only the faintest scars for some future intelligence to puzzle over. And so we arrive at the unsettling possibility that the Earth may have hosted other stories, other civilizations, long before ours. If they were short-lived, if they rose and fell in the span of a few tens of thousands of years, then deep time would swallow them whole. We assume we are the first. We assume intelligence is rare. But those assumptions rest on evidence that is, by the nature of geology, incomplete. The truth is, the further back we look, the less certain we can be. Our blind spot is not just ignorance, it is structural. The very processes that shape Earth also erase its memory. What we see is not the full story, but a heavily redacted version. And in those redactions, who knows what chapters have been lost. If we are not the first civilization to have risen on Earth, then the ruins of our predecessors will not present themselves as stone cities preserved beneath the sands or fossilized machines waiting in caves. No, the Earth is too cruel a keeper for that. Its surface is restless, endlessly reshaping itself through the slow violence of erosion, volcanism, and tectonic drift. Whatever once stood upon it is eventually dragged down into the furnace of the mantle or worn away into dust. What remains are not monuments, but fingerprints. Subtle scars left in the rocks and soils, chemical echoes of choices once made, faint anomalies that speak of something that should not have been there. If we are to search for forgotten civilizations, we must learn to read these scars, and to ask ourselves a question both unsettling and thrilling. If another industrial age had risen long before us, what would its fingerprints look like? The most obvious place to begin is with carbon, the lifeblood of our own civilization. Every year we dig up billions of tons of coal, oil, and gas, carbon that was buried hundreds of millions of years ago, locked away in deep strata, compressed into fossil fuels by heat and time. When we burn these fuels, we release carbon dioxide into the air, thickening the atmosphere, warming the climate. But more importantly, we alter the chemical balance of that carbon itself. The isotopic fingerprint of fossil carbon is slightly lighter than modern organic matter, with more carbon-12 and less carbon-13. As we pour it into the atmosphere, that balance shifts in a measurable way. Future geologists drilling into the sediments of our age will see it as a sudden global deviation in the carbon isotopic ratio, what scientists today call the Seuss effect. It is like a chemical signature carved into the air itself, captured in the rock record forever. And here is where the story takes a darker turn. This kind of anomaly has been seen before. 56 million years ago, the Earth experienced what is known as the Paleocene-Eocene thermal maximum, a sudden burst of global warming. Temperatures soared, oceans acidified, ecosystems collapsed. In the rocks, we find a sharp carbon isotopic shift, almost identical to the one happening now. Scientists argue about its cause, perhaps volcanic outgassing, perhaps methane erupting from frozen seafloor clathrates. But the truth is, we do not know. The anomaly looks disturbingly like the fingerprint of fossil fuel burning. Could it have been natural? Almost certainly. And yet, the uncomfortable possibility lingers. If another civilization had lived and died in that ancient age, this is exactly the kind of scar they would have left behind. And it is not the only event like it. 250 million years ago, at the end of the Permian period, the Earth suffered the greatest extinction in its history. More than 90% of marine species, 70% of land species, gone in a geological heartbeat. The rocks tell us that carbon flooded the atmosphere, the oceans turned toxic, the climate became unlivable. Volcanism in Siberia is blamed, releasing trillions of tons of greenhouse gases. But again, to a geologist reading that record without preconceptions, the signal is eerily similar to industrial activity on a scale we can barely imagine. Were it not for our assumption that industry did not yet exist, who is to say what story we might read in that stone? If carbon is one fingerprint, then plastic is another, a far stranger one, for it is wholly alien to the natural world. In the few decades since we invented it, plastic has spread across the earth like a second skin. It rides the winds, drifts in the seas, sinks to the abyssal plains. It is eaten by plankton, fish, and whales, broken into fragments no larger than dust. Already, the sediments of modern riverbeds and coastlines contain measurable layers of microplastic. Buried by new strata, these fragments will fossilize, becoming a permanent part of the geological archive. Some will even fuse with sand, rock, and shell to form plastiglomerates, strange hybrid stones that never existed before humanity. Picture a geologist 50 million years in the future, hammering open a cliff face. They see a thin, glittering seam in the strata, filled with odd glossy fragments. The microscope reveals long chains of synthetic polymers, molecules that no natural process could assemble. What would they think? Would they realize at once that these were the relics of industry? Or would they puzzle over them as chemical curiosities, perhaps attributing them to some bizarre volcanic process? If we are not careful, perhaps we ourselves have already dismissed such anomalies in older rocks, never guessing that they could be the relics of something ancient and lost. Metals tell a similar story. Our world is saturated with them: iron and copper for wires and structures, tungsten and rare earth elements for electronics, aluminum for everything from airplanes to soda cans. But in nature, pure aluminum almost never occurs. It exists locked in minerals like bauxite. It is only through smelting, through industrial alchemy, that we create the metal in bulk. Should it be buried and preserved, these refined metals will leave behind peculiar concentrations, strange patterns in soils and sediments. Aluminum, titanium, tungsten, all in ratios no natural process would ever produce. Future geologists might scratch their heads, noting the anomaly without understanding its cause. But the scar would remain, the silent testimony of industry. And we must consider the scars we carve into the land itself. Mines that gouge deep into the crust, pits visible from orbit, valleys stripped of their stone. If buried, they might someday appear as odd hollows in ancient strata, puzzling depressions filled with unusual fill material. Deforestation, too, leaves its mark. In our pollen record today, the rise of agriculture is unmistakable. Forests vanish, replaced by vast monocultures of wheat, corn, and rice. Even if the plants themselves do not fossilize, the pollen grains do, tiny indestructible markers of our reshaping of ecosystems. Imagine another civilization plowing fields on a global scale 100 million years ago. Would its agricultural signature survive? Almost certainly. Would we recognize it for what it was? That is less certain. And then there is the most haunting fingerprint of all: the nuclear shadow. In less than a century, our species has detonated hundreds of nuclear devices, each releasing a storm of artificial isotopes into the sky. Cesium-137, strontium-90, plutonium-244, atoms that do not occur naturally in measurable quantities. They settle into sediments, ice, and soil, forming a thin layer spread across the entire globe. Even 10,000 years from now, long after our monuments have crumbled, this radioactive line will remain. It is perhaps the clearest signal that could be read as evidence of intelligence, unmistakable in its artificiality. And yet, the chilling question lingers. If we were to find such isotopes in ancient rocks, would we dare to interpret them as signs of a vanished civilization? Or would we, bound by our assumptions, strain for a natural explanation, perhaps blaming cosmic rays or supernova dust. Indeed, natural nuclear reactors once existed. In Oklo, Gabon, 2 billion years ago, uranium deposits went critical and sustained nuclear fission for hundreds of thousands of years. The isotopic scars remain, baffling scientists until the phenomenon was understood. Imagine, then, how easily we might misinterpret genuine artificial isotopes from an ancient civilization as some strange quirk of natural chemistry. Our caution, our bias toward natural explanations, may blind us to the truth even when it lies in stone before us. And finally, extinction itself may be the loudest fingerprint of all. Industrial civilization transforms ecosystems, drives species to collapse, and replaces biodiversity with monocultures. We live in the midst of what biologists call the sixth mass extinction, with species vanishing at rates rivaling the asteroid strike that ended the age of dinosaurs. In the rocks of the future, this will appear as a sudden reduction in species diversity, a narrowing of forms, the rise of opportunistic survivors, rats, crows, cockroaches, spread across the globe. It will be a sharp break in the fossil record, as abrupt and global as the extinction at the end of the Cretaceous. But the Earth has suffered mass extinctions before, 5 great ones and many smaller crises. In each, the fossil record shows the same pattern. Diversity collapses, ecosystems reorganize, life begins anew. The causes we attribute asteroids, volcanism, climate shifts are based on the evidence we can see. But if an industrial civilization had played a role in any of them, its fingerprints would look strikingly similar. Without knowing to ask, would we ever consider that possibility? Or would we simply fold it into the narrative of natural catastrophe, never suspecting that something more deliberate lurked beneath? What emerges from all of this is a paradox. The fingerprints of industry are real and measurable: carbon isotopes, plastics, metals, nuclear isotopes, extinction patterns. They will remain long after cities crumble and bones turn to dust. But none of them are entirely unique. Nature, too, produces carbon spikes, strange rocks, radioactive traces, and extinction events. The difference between the artificial and the natural is not always clear in the deep record of geology. What to us is unmistakably the scar of civilization might to a future scientist look like nothing more than a natural anomaly. And what to us today appears as a natural anomaly in the deep past might, in truth, be the faint ghost of a civilization erased by time. If we vanish tomorrow, our story would not be entirely lost. Future geologists would find the bomb spike, the plastiglomerates, the isotopic shifts. They would know, at least dimly, that someone had been here, that industry once flared upon this planet. But when we look backward into the unfathomable depths of hundreds of millions of years, we do not have that luxury. The Earth has rewritten too much of itself, buried too many chapters, burned too many pages in the furnace of its mantle. What we see is not the whole story, but a heavily redacted version. And in those redactions, who knows what has been lost? This is the true weight of the Silurian Hypothesis. It is not that we can prove ancient civilizations existed, but that we cannot prove they did not. The scars we should expect are the very scars the Earth already bears: carbon anomalies, chemical shifts, extinction events. The question is not whether such fingerprints exist, but how we choose to interpret them. Are they the work of geology alone, or whispers of something older, something forgotten? Perhaps in the end it does not matter. Whether or not others came before us, the message is the same. We too will be reduced to whispers. Our skyscrapers and satellites will vanish. Our languages and cultures will be forgotten. Our achievements scattered like dust. What will remain are the fingerprints, the carbon scars, the plastic stones, the radioactive shadows. Long after we are gone, the Earth will remember us not in monuments, but in chemistry. And if others ever walked this path before, then perhaps they, too, are remembered in chemistry alone. The Earth keeps its secrets well. Across the centuries, long before modern scientists gave the Silurian Hypothesis its name, human beings have stumbled upon puzzles in the Earth, anomalies that refuse to sit comfortably in the timeline we have built for ourselves. They are the things that do not belong. A hammer buried in stone, an object of metal pulled from coal seams, a pattern on the seabed that seems too regular, too intentional to be chance. Most of these finds are dismissed, often with good reason. But the dismissals do not erase the questions. They linger in the imagination, forming a shadow history, a sense that our story may not be the first story told on this world. The most dramatic examples come from what some call OPArts, out-of-place artifacts. These are objects found in geological contexts that seem impossibly old. A famous case is the London hammer, discovered in Texas in the 1930s. A simple iron tool encased in a concretion of rock that geologists estimate formed millions of years ago. Mainstream science explains the concretion as a relatively recent mineralization process, water percolating through stone, binding sediments around a modern object until it appears ancient. But to those drawn to alternative histories, the hammer is a symbol, a whisper of technology buried deep in time. If even one such object were truly as old as its stone prison, it would overturn everything we think we know about the history of life on Earth. And there are others. In Russia, miners in the 1990s reported finding tiny metallic spirals, some less than a millimeter in length, embedded in sediments dated to hundreds of thousands of years ago. Under the microscope, the spirals looked like manufactured coils, not natural crystals. Some dismissed them as shavings from drilling equipment, contaminated samples. Others insisted they represented something more extraordinary, perhaps remnants of machinery, unimaginably ancient, too small to be understood by the civilizations we know. Even if they were not, the fact that such debates arise at all speaks to the hunger in us for something older, something stranger, than the narrow window of our recorded past. Coal, too, has yielded its share of mysteries. Workers in the 19th and early 20th centuries sometimes claimed to discover nails, chains, or other metallic fragments sealed inside coal seams that were tens of millions of years old. Explanations vary. The objects could have been dropped during mining, or intrusive cracks could have allowed modern debris to work its way in. Yet every so often, the reports resurface, recirculated as evidence that perhaps, buried in the darkness of the Carboniferous, there was once fire, forge, and industry. Science says no, but imagination refuses to let go. Of course, not all anomalies are artifacts. Some are geological features that simply look artificial. Off the coast of Yonaguni, Japan, divers discovered what appears to be a massive stone structure, with steps, terraces, and platforms. Some researchers believe it to be natural, the product of wave action and fracturing rock. Others argue it shows signs of deliberate shaping, a lost monument submerged by the sea thousands of years ago. Mainstream archaeology places no advanced culture in Japan so far back. But to those who stand on its ledges, staring down stairways that plunge into the abyss, it is difficult not to feel that human hands, or perhaps some other hands, once left their mark. Similar debates swirl around other megalithic sites. The enormous blocks at Baalbek in Lebanon, weighing hundreds of tons, cut with precision and moved with a skill that challenges even modern engineering. Archaeologists attribute them to the Romans, who had remarkable abilities in stonework. But whispers persist that the Romans themselves were inheritors, not builders, that the stones may belong to an older stratum of human history. And while Baalbek's date is at least known within the Holocene, the mere possibility of cultural memory reaching further back makes us wonder. If civilizations can forget so much in just a few thousand years, how much could be lost in 1,000,000? Or 100 million? Then there are the maps. The Piri Reis map, drawn in the 16th century, appears to depict the coastline of Antarctica without ice, though Antarctica has been buried in glaciers for millions of years. Mainstream historians argue that the map is a collage of earlier sources, distorted and misinterpreted. But to those who seek deeper histories, it is a clue suggesting that seafarers or someone charted lands long before modern civilization could have done so. Could echoes of a civilization long vanished have filtered through into ancient lore, surviving only as fragments copied into maps by Ottoman admirals? Beyond human history, the rocks themselves sometimes tell stories that raise eyebrows. The so-called spherules of rare metals, like iridium and platinum, scattered across multiple geological boundaries, are usually explained as the fallout of asteroid impacts. Most famously, the iridium spike at the Cretaceous-Paleogene boundary, 65 million years ago, marks the cataclysm that ended the reign of the dinosaurs. But what if, in some cases, such deposits were not solely the result of cosmic collisions? In our time, metallic spherules rain from industrial smokestacks, tiny globules formed by intense heat. They scatter across the globe, indistinguishable at first glance from natural microspherules formed in volcanic eruptions or impacts. When future geologists look back at our age, they will find them everywhere, proof of industry. Could we already be looking at such a signal from another time, only assuming it was born of fire and stone, not furnace and forge? Perhaps the most provocative anomalies are not physical objects at all, but stories, myths and legends passed down through cultures separated by oceans, yet strangely similar in their themes. Tales of golden ages, floods that wiped the earth clean, gods who descended from the skies bringing knowledge and technology. Skeptics see them as archetypal human storytelling, metaphors for cycles of nature or moral instruction. But others wonder, could they be dim cultural memories of something real? If civilizations rose before, were they destroyed in cataclysms so total that only myth remained, whispered around fires until history swallowed the details and left only the bones of story? Mainstream science, of course, offers reasonable explanations for each anomaly. Rock concretions can form quickly. Metal spirals might be industrial waste. Stone formations can fracture into shapes that fool the eye. Myths can emerge independently in different societies because humans share similar experiences of nature. All of these are true, and yet the sheer persistence of anomalies, the way they appear again and again, from mines to seabeds to libraries, makes them impossible to entirely dismiss. They act as pressure points in the narrative of human uniqueness, cracks in the armor of certainty. If another civilization had risen millions of years ago, we should not expect to find intact machines or skyscrapers. Time would have ground them to dust. But the occasional artifact, the puzzling spherule, the inexplicable pattern in stone, these are precisely the kind of echoes we might stumble upon. They might mean nothing, or they might mean everything. The difficulty lies in knowing which. And so, when scientists speak of the Silurian Hypothesis, they are not claiming proof, nor arguing that the anomalies scattered across history are evidence of forgotten empires. Rather, they are saying something subtler and, in some ways, more unsettling. That even if such civilizations had existed, the evidence they left behind would look very much like anomalies we already see. Natural explanations may be correct and likely are, but we cannot be entirely sure. This uncertainty is what fuels both science and imagination. It forces us to look harder at the record, to refine our tools, to question our assumptions. For the Silurian hypothesis does not only ask us whether others once lived here, it asks us how well we truly know our planet's memory. If our own story can be so easily buried beneath the churn of geology, how much of the Earth's past has already been lost to fire, to water, to the slow grinding of continents? Every anomalous find, whether debunked or unexplained, is a reminder that history is not a closed book, but an incomplete manuscript, with pages missing, ink smudged, and margins crowded with half-erased notes. Perhaps the hammer in stone is only an illusion. Perhaps the coils are nothing more than shavings. But perhaps, too, they are the faintest footprints of civilizations erased by time, their stories long gone, leaving behind only riddles. And the deeper we dig, the more we must confront a possibility as vast as it is humbling. That the Earth may have hosted not one, but many rises and falls of intelligence. We may be just the latest to walk this path, not its originators. The anomalies are not proof. They are the whispers, and sometimes whispers are all that remains. The Silurian hypothesis begins as a narrow question, a puzzle about geology and the possibility of forgotten civilizations. But the longer you dwell on it, the more it expands, until it touches not only the history of Earth but the destiny of all life in the universe. It asks not just, did anyone come before us? But are we alone in time? Are we alone in space? And even, what does it mean to be a civilization at all? For most of human history, we looked upward and imagined the heavens filled with neighbors. Ancient philosophers wrote of infinite worlds, each peopled by beings like or unlike ourselves. In the 19th and early 20th centuries, astronomers looked at the canals of Mars and speculated that they were the works of engineers. In the golden age of science fiction, the galaxy was imagined as crowded and buzzing with intelligent life. Yet, in the cold clarity of modern astronomy, we find instead silence. No beacons beam across the stars. No vast machines dim their suns. No spacecraft drift in to greet us. It is a silence so deep and so puzzling that it has become one of the great scientific enigmas of our age. This silence is what we call the Fermi paradox. If the universe is old and vast, if billions of stars have planets, and if life is not rare, then where is everyone? The most unsettling answer is that civilizations may bloom like flowers, briefly bright and alive, but destined to wither quickly. If intelligence is fragile, if it burns itself out or falls victim to catastrophe, then most civilizations may be ghosts long before they could ever signal across the void. The galaxy could be teeming with the ruins of minds, each one extinguished before we arrived to hear it. The silence, in that case, is not emptiness but aftermath. And the Silurian hypothesis pushes this idea further still. What if the same pattern holds not just across space but across time? What if intelligence on Earth itself is not unique, not singular, but part of a cycle, a phenomenon that can rise, flourish, and vanish, only to be forgotten and perhaps to reappear again? When we speak of being the first civilization, we assume the planet has been waiting for us. But the Earth is 4.5 billion years old. Complex multicellular life has thrived for over 500 million years. Dinosaurs reigned for more than 150 million years. 25 times longer than humans have even existed in recognizable form. Mammals have been evolving for over 200 million years. In all that time, is it truly impossible that another branch of life might have climbed the ladder of intelligence and culture, only to be erased by the same forces that constantly reshape our world? We are so conditioned to see ourselves as unique that we rarely pause to consider how brief our reign has been. Civilization as we know it, with writing, agriculture, and cities, is only about 10,000 years old. That is the tiniest fraction of Earth's story, less than the blink of an eye in geological time. If we vanished tomorrow, in 10 million years it would be as if we had never existed, except for a faint chemical line in the rocks. So if another species had risen 50 million years ago, or 100 million, or even more, how would we know? Their bones would be dust, their monuments ground to sand, their cities subducted into the mantle. All that might remain would be ambiguous anomalies, chemical fingerprints, subtle layers of ash, odd isotopes scattered in stone. In other words, exactly what we are leaving behind right now. The Fermi paradox suggests that civilizations may almost always destroy themselves before achieving lasting permanence. If that is true, then the Earth itself may have experienced multiple cycles of intelligence. Imagine, for a moment, a reptilian lineage in the warm Eocene, descendants of creatures that survived the extinction of the dinosaurs. Perhaps they developed tools, culture, even industry. They might have burned forests, altered their climate, left subtle scars in the sediments. But in the great sweep of time, they fell, through collapse, disaster, or evolution's endless churn, and their world was forgotten. Millions of years later, mammals rose, and eventually us. To us, they would be as invisible as we might someday be to whatever comes after. Or picture the Carboniferous swamps, 300 million years ago, where dragonflies with wingspans the size of hawks drifted above endless forests. Those forests created the coal that we burn today. Could some lineage of amphibians or arthropods have climbed to intelligence then, in a world rich with resources and oxygen? If they had, they too would now be nothing more than shadows, erased by the rolling march of continents and oceans. We assume it never happened because we see no obvious ruins. But the Earth is not kind to ruins. The very ground we stand on is recycled, crushed, melted, reborn. Time does not preserve easily. In this sense, the Earth itself mirrors the galaxy. The silence of deep time is like the silence of the stars. We search for signals and see none. But absence of evidence is not evidence of absence. It is simply a reminder of the limits of our vision. We see only what the Earth chooses to preserve, and we hear only what the stars have not yet forgotten. And what would it mean if intelligence is not unique? It would mean that life tends toward it, that consciousness is not a fluke but a recurring motif, a crest that evolution reaches again and again given the chance. That idea is both inspiring and sobering. Inspiring, because it suggests we are part of a grander story of the universe, not a lonely accident but one expression among many. Sobering, because if others have come before and are gone, then intelligence may not guarantee survival. Great minds may rise, but the universe does not promise them permanence. This brings us back to the Fermi paradox. Perhaps the reason we do not see civilizations among the stars is not that they never existed, but that they rarely endure. They may burn themselves out with war, with environmental collapse, with resource exhaustion, or they may simply be erased by natural catastrophes. Asteroids, supervolcanoes, stellar flares. Each becomes a ghost civilization, its works reduced to fragments or buried in silence. The same may be true of Earth. Perhaps we are not the first spark of intelligence here. Perhaps we are simply the latest, and our fate may be no different unless we learn from the silence around us. But there is another possibility, one even stranger. What if intelligence does not simply repeat, but leave faint threads of continuity? What if myths of golden ages and gods are distant cultural memories, not of humans but of something older? What if the very notion of time itself, as we experience it, blinds us to cycles longer than our recorded history? In that view, the Earth could be like a palimpsest, a manuscript written and rewritten, each new text half erasing the one before. We are reading only the latest version, while the older stories lie hidden beneath, their ink faded but not gone. And what if this same cycle plays out across the cosmos? Planets bloom with life, rise to intelligence, and collapse. Each time, the record is mostly lost. The galaxy we see as empty may instead be filled with these erased histories. Civilizations rise, but their voices never overlap. They are separated not just by space, but by time. In this view, the silence of the galaxy is not absence but loneliness, the loneliness of being alive at different moments in a vast cosmic story. We are like travelers arriving at a great library where the shelves are empty, only to discover that the books were there once, but they have crumbled to dust in the ages before our arrival. And what of us? What does it mean for humanity to see itself through this lens? It means that permanence is not guaranteed. Our skyscrapers, our satellites, our archives, they feel enduring, but they are fragile in the scale of millions of years. If we wish not to become another faint, ambiguous anomaly in the rock record, then we must learn to endure. We must find ways to live within the limits of our world, to preserve not only our environment but the continuity of our story. For if we vanish, the Earth will remember us only as chemistry, and perhaps some future mind will stand where we stand and wonder, as we do now, whether they were truly the first. In this way, the Silurian hypothesis transforms from a scientific curiosity into a mirror. It forces us to confront both our fragility and our potential. We may not be the first to rise, and we may not be the last. But we are here now with the power to decide whether our chapter ends as a whisper, or whether it endures long enough to be more than a single thin layer in stone. We live in an age where permanence feels natural. Cities rise across continents, glowing with light even when viewed from orbit. Highways stretch endlessly, connecting billions of people. Great towers pierce the sky, monuments of steel and glass, as if to announce that human achievement is not fleeting, but eternal. We build archives of information so vast that they seem unerasable. We scatter satellites around our planet and leave probes at the edges of the solar system, convinced that our fingerprints are indelible. Yet this sense of permanence is an illusion. History tells a different story, and geology tells an even harsher one. What the Silurian hypothesis forces us to confront is that civilizations are not guaranteed to last, and in deep time, almost nothing endures. Consider the empires of our own species. Once, Rome stretched across Europe, Africa, and the Middle East, its roads tying together a vast territory, its legions feared, its cities filled with aqueducts and amphitheaters. Romans believed their empire would last forever. Yet it collapsed, reduced to fragments, its monuments left to crumble. The Mayan civilization built vast stone pyramids and cities in the jungles of Central America, complete with writing, astronomy, and complex agriculture. Their knowledge was immense, their culture vibrant. But they too fell, leaving only ruins swallowed by the forest. The Sumerians of Mesopotamia, the Harappans of the Indus Valley, the great dynasties of China, all of them rose with brilliance, then waned. The ruins remain, but even they are fragile. Without deliberate preservation, they too would vanish into dust. And these collapses are not limited to human history. They are written into the fabric of life itself. For over 150 million years, dinosaurs ruled the earth. They filled every niche. Predators, grazers, scavengers, creatures that swam, creatures that flew. Their dominance lasted 25 times longer than all of human history. Yet they were erased in a geological instant, struck down by a catastrophe from the sky. Their bones became stone, their memory reduced to fragments. If such rulers could vanish so easily, what hope do we have that our fragile civilization, barely 10,000 years old, could resist the same forces? The Earth has seen 5 great mass extinctions. The Ordovician, the Devonian, the Permian, the Triassic, the Cretaceous, each one a reset button, wiping out most of life and giving evolution a fresh slate. Species that thrived for hundreds of millions of years vanished completely, leaving not even a shadow in the present. The Silurian Hypothesis reminds us that if any of those vanished creatures had reached intelligence, we would never know. Their civilizations, their languages, their stories would be gone, erased more thoroughly than Rome, more thoroughly than the Mayans, more thoroughly than anything we can imagine. We assume we are first because we cannot see the past. But what if that blindness is simply the nature of deep time? And so we must ask, what would make us different? Why should humanity succeed where others, whether imagined or real, have failed? The answer cannot lie in arrogance, cannot lie in believing that our intelligence alone will save us. History shows that intelligence is not immunity. The brightest minds of the 20th century created nuclear weapons capable of annihilating civilization in hours. The same technological brilliance that gives us satellites and medicine also threatens us with artificial intelligence we may not control, genetic manipulation we may not understand, and ecological destruction we may not repair. Knowledge is power, but power cuts both ways. Let us consider the dangers we face. Nuclear war remains one of the most immediate. The Cold War brought the world to the brink more than once, and though decades have passed since those darkest days, the weapons still exist, thousands of them, enough to destroy not only cities but climates. A full-scale exchange could plunge the world into nuclear winter, shrouding skies in ash, collapsing harvests, and starving billions. If humanity were to fall that way, the record left in the rocks would look strikingly like the anomalies we seek when pondering ancient civilizations. Soot layers, radioactive isotopes, sudden die-offs in the fossil record. If the Silurians existed, perhaps they too ended in fire. Climate change is another danger, slower but no less deadly. By burning fossil fuels, we alter the atmosphere, trapping heat, melting ice, raising seas, shifting storms. Species vanish as habitats collapse. Ocean chemistry changes as carbon dioxide dissolves into the waters. If left unchecked, our climate could spiral into instability, and the Earth would not forgive us. Geology remembers such events. 55 million years ago, the Paleocene-Eocene thermal maximum saw a massive release of carbon, spiking global temperatures. Life survived, but it was transformed. If we vanish in a similar upheaval, the rocks will show it. A sharp line of carbon isotopes, sudden extinctions, a world reshaped. Another anomaly for another future intelligence to ponder. Asteroids lurk in the skies. We know they have struck before and they will strike again. The one that ended the Cretaceous was only 10 kilometers wide, yet it erased 70% of all species. If one were to strike today, our cities would be shattered, our global systems collapsed. We might not recover. Supervolcanoes sleep beneath our feet, capable of spewing ash and gas into the atmosphere for years, darkening the sun and cooling the earth. Such eruptions have happened before. They will happen again. We cannot stop them. At best, we can endure them. And then there are the dangers of our own creation. artificial intelligence that may outpace our control, biotechnology that could unleash pandemics beyond containment, nanotechnology that could spiral out of hand. Each new tool gives us power but also risk. The history of humanity is the history of playing with fire. Each time we survive, we grow stronger. But one mistake, one miscalculation could end us. So what lessons can we draw? First, humility. We must recognize that we are not inevitable, not permanent, not guaranteed. We are fragile. Our survival depends on our choices. Second, foresight. We must think not in terms of years or even centuries, but in terms of millennia and millions of years. If we want to endure, we must act as if the distant future matters, because it does. Third, stewardship. We are not masters of the earth but caretakers. If we destroy the balance of the systems that sustain us, we will fall. If we preserve them, we may thrive. But there is also hope. Unlike any species before us, we have the ability to look forward as well as backward. We can imagine futures and plan for them. We can build technologies not only to destroy but to protect. We can track asteroids and, perhaps, deflect them. We can monitor volcanoes and prepare for their eruptions. We can adapt our energy systems to prevent catastrophic climate change. We can learn from history, not only our own, but the history of life itself. We must also think beyond Earth. As long as we are confined to a single planet, we are vulnerable. A single catastrophe could end us. But if we spread to other worlds, Mars, the moons of Jupiter and Saturn, perhaps one day beyond the solar system, we increase our chances of survival. The dinosaurs had no space program. If they had, they might still be here. That is perhaps the most profound lesson of all. To endure, intelligence must expand. It must carry itself beyond the cradle of its birth. The Silurian Hypothesis, in this light, becomes more than a question of curiosity. It becomes a warning. If others came before and failed, then we must learn from their silence. We must ask why they vanished, even if we never find proof they existed. The very act of considering them forces us to think about our own fragility. And that may be their greatest gift, not evidence but perspective. Imagine millions of years from now, another species digging through the rocks of the Anthropocene. They find traces of carbon, metals, plastics, radioisotopes. They wonder, who were these creatures? How did they live? Why did they vanish? Did they know what they were doing? Did they see the danger? Did they try to endure? We can only hope that if such a species arises, they will not find our story cut short. We can hope they will find that humanity did not vanish, but transformed, expanded, endured. The lesson for humanity is clear. Survival is not a gift. It is not a right. It is something we must earn, day by day, century by century, age by age. If we fail, we will be forgotten. If we succeed, we can become more than a footnote in the Earth's story. We can become the first species to defeat the silence, the first to endure across deep time, the first to ensure that the story of intelligence is not a cycle of rise and fall, but a journey that continues upward, outward, forever. For all the wonder and speculation of the Silurian Hypothesis, one question looms larger than all the rest. If there really was a civilization before us, where is the proof? It is one thing to imagine intelligent reptiles in the Eocene or tool-wielding amphibians in the Carboniferous, but science demands evidence. Without it, the Silurian Hypothesis remains a thought experiment, an intellectual challenge to sharpen our thinking. To move it beyond speculation, we would need to find something undeniable, something that cannot be explained away by chance geology or natural chemistry. And so the search begins. To understand what this search would look like, we have to imagine the Earth not as it is now, but as it works over millions of years. Our planet is not static. It is alive with change. Mountains rise and crumble, seas advance and retreat, continents drift like rafts across the mantle. Volcanoes bury landscapes in ash, glaciers grind valleys into stone. Rivers carve canyons deeper than the tallest skyscrapers. In such a world, ruins do not last. A city left untended will collapse in centuries, be buried in millennia, and erased in millions of years. Even the pyramids of Egypt, which seem eternal, will one day be dust. If we want to find a civilization from deep time, we must know where to look. One of the first places scientists consider is the chemical record. Rocks hold stories, written not in letters but in isotopes and molecules. When humans burn fossil fuels, for example, we release carbon dioxide into the air. That carbon carries a distinct isotopic fingerprint, lighter than the carbon locked in limestone or the shells of ancient organisms. Geologists of the far future would see a sharp spike in these isotopes during the Anthropocene, our age. If another civilization had burned fuel or altered their atmosphere, they too might have left a similar chemical scar. Scientists can scan rock layers for sudden, unnatural shifts in carbon ratios, for traces of metals in concentrations too high to be natural, for compounds that should not exist without technology. Already, there are anomalies in Earth's past that raise questions. Abrupt spikes in greenhouse gases, layers rich in metals like platinum and iridium, sudden die-offs of species. Most can be explained by natural events like volcanic eruptions or asteroid impacts. But the question remains, could one or two of them hint at something more? Plastics are another clue. Nothing in nature produces them in abundance. If a civilization used plastics, traces might persist as microscopic fragments, buried in sediments that become future rock. Already, geologists today speak of the plastoglomerate, rocks fused with melted plastic found on beaches. Millions of years from now, such materials might still be detectable. If we dig far enough into ancient strata and find similar plastic residues, what would that mean? Did some earlier intelligence leave behind its own disposable culture, long since reduced to molecules? Then there is the question of radioactivity. Human industry has released isotopes into the environment that do not occur naturally in significant amounts. Cesium-137, plutonium-239, and other products of nuclear fission are spread across soils and oceans. These isotopes decay, but their daughter products remain. Millions of years from now, a future geologist might detect a thin radioactive horizon in the rocks, marking our time. If another civilization had split the atom before us, might they too have left a similar line, a radioactive fingerprint in ancient stone? Geologists also think about unusual sediments. Industrial societies mine, refine, and distribute materials in ways that nature does not. Layers enriched in certain metals, aluminum, titanium, rare earth elements, could point to technological use. Large-scale agriculture could alter pollen records, showing sudden shifts in plant distributions. Dams and reservoirs could change sedimentation patterns in rivers. Even the absence of expected fossils could tell a story if mass extinctions coincided with chemical shifts. But perhaps the most haunting clue lies in the fossil record itself. Imagine discovering bones not of humans but of something altogether alien, an intelligent reptile, an upright mammal not known to science, a creature with hands capable of tools. Fossilization is rare, but not impossible. If such a skeleton were found in a rock layer, tens of millions of years old, with no evolutionary explanation, it would shake the world. Yet so far, Nothing like that has been uncovered. Every fossil we know fits into the broader tree of life. If the Silurians walked the Earth, their bones are dust. This is why scientists broaden the search from Earth to other planets. Mars, with its dry surface and thin atmosphere, preserves its history better than Earth does. Rocks there have lain undisturbed for billions of years. If Mars once held life, even civilization, its ruins would be far better preserved than ours will ever be. Likewise, Venus, though hellish today, may once have been temperate and wet. If it supported life before its runaway greenhouse, then perhaps its crust holds secrets. Even the moons of the outer planets, Europa and Enceladus Titan, are candidates. If intelligence arose there and fell, could we detect it? The Silurian hypothesis forces us to widen our search. We cannot assume Earth was the only stage for intelligence. And so, searching for proof becomes not just a geological pursuit but a planetary and even cosmic one. We must train our instruments to see not only natural processes but also the faint signatures of the unnatural. When astronomers scan exoplanet atmospheres for signs of life, they also think of technosignatures, gases or chemicals that suggest industry, not biology. On Earth, the same principle applies. To search for ancient civilizations is to search for technosignatures in stone, in ice, in fossil, and in mineral. Of course, skeptics argue that this search is quixotic. The Earth is too good at erasing. Civilizations, if they ever arose before us, would be swallowed by tectonics and weather. What we find in the rocks can always be explained by volcanoes, by asteroids, by natural cycles. And yet, science thrives on questions that push its boundaries. The Silurian hypothesis may never be proven, but in searching for proof we sharpen our methods, we learn more about our planet, and we uncover mysteries we might otherwise overlook. And here is the final irony. In searching for others, we find ourselves. The same techniques that might reveal an ancient civilization also reveal the scale of our own impact. When geologists search for isotopic spikes, they find our carbon. When they analyze sediments, they find our plastics. When they measure radioactivity, they find our weapons. The proof we seek for others is already undeniable for us. We are the anomaly. We are the chemical scar. We are the civilization that future geologists will wonder about. And that may be the most haunting proof of all, not of them, but of us. The search for an ancient civilization buried in Earth's deep past leads us down extraordinary paths, but science always requires us to ask, what else could explain these anomalies? If we find unusual carbon signatures in rocks, strange metal concentrations, abrupt die-offs of species, or layers of debris scattered across continents, the first responsibility is not to leap to lost civilizations, but to investigate the natural processes that could have produced them. One of the most powerful forces shaping Earth's past is volcanism. Throughout history, colossal eruptions have poured fire into the sky and ash across the world. The Siberian Traps, for instance, erupted around 252 million years ago, in an event so massive it covered an area larger than modern Europe with layers of basalt rock. For nearly 1 million years, volcanoes belched carbon dioxide and sulfur into the atmosphere, triggering runaway greenhouse warming, acid rain, and the collapse of ecosystems. The Permian-Triassic extinction, which followed, wiped out around 90% of all species. In the rocks, this looks like an abrupt, global chemical shift. If we didn't know about volcanism, we might imagine an industrial civilization pumping greenhouse gases into the air. In truth, nature itself can outdo even our most ambitious pollution. Asteroid impacts are another explanation for strange signatures in the geological record. The most famous example is the Chicxulub impact, the 6-mile-wide asteroid that struck Earth 66 million years ago and ended the reign of the dinosaurs. The force of the collision released the energy of billions of nuclear bombs, vaporizing rock, igniting global wildfires, and plunging the planet into darkness. Across the world, rocks from that time contain a thin layer enriched with iridium, a metal rare in Earth's crust but common in asteroids. They also contain tiny glassy spherules, droplets of molten rock blasted into the sky and cooled as they fell. To a geologist millions of years in the future, such a layer might look eerily like the debris of a nuclear war. Yet in this case, it was not civilization but blind cosmic chance that scarred the Earth. There are also events that look suspiciously industrial but have purely biological origins. The Great Oxidation Event, more than 2 billion years ago, transformed Earth's atmosphere from a world without oxygen into one rich with it. Tiny microbes capable of photosynthesis multiplied across the planet, releasing oxygen as waste. To the rocks, this was a sudden, dramatic chemical shift. Iron rusted in oceans, leaving vast deposits of banded ironstone. Methane was destroyed in the air, plunging the Earth into a series of ice ages. If a geologist from another world studied those rocks, they might think an advanced civilization had deliberately terraformed the planet. In truth, it was the slow, relentless work of bacteria. Even more recently, natural cycles can create anomalies that look artificial. Sudden climate changes have left sharp lines in ice cores and sediments. Shifts in ocean currents can alter carbon deposits in ways that mimic industrial burning. Meteor showers leave scattered traces of exotic metals. Even lightning strikes can fuse soil into glassy fragments. The Earth is full of strange processes, many of which could fool us into seeing the hand of intelligence where there is none. But this does not mean the Silurian hypothesis is meaningless. Quite the opposite. Its very power lies in the way it forces us to test every anomaly, to ask not just what happened but what else could it mean. Consider plastics. If geologists millions of years from now found tiny synthetic polymers in rocks, they might puzzle over their origin. Perhaps they would assume some rare chemical process in ancient oceans. But the Silurian hypothesis reminds us to keep a wider perspective. Sometimes the simplest answer is natural, but sometimes it is not. To a geologist millions of years in the future, such a layer might look eerily like the debris of a nuclear war. Yet in this case, it was not civilization but blind cosmic chance that scarred the Earth. There are also events that look suspiciously industrial but have purely biological origins. The Great Oxidation Event, more than 2 billion years ago, transformed Earth's atmosphere from a world without oxygen into one rich with it. Tiny microbes capable of photosynthesis multiplied across the planet, releasing oxygen as waste. To the rocks, this was a sudden, dramatic chemical shift. Iron rusted in oceans, leaving vast deposits of banded ironstone. Methane was destroyed in the air, plunging the Earth into a series of ice ages. If a geologist from another world studied those rocks, they might think an advanced civilization had deliberately terraformed the planet. In truth, it was the slow, relentless work of bacteria. Even more recently, natural cycles can create anomalies that look artificial. Sudden climate changes have left sharp lines in ice cores and sediments. Shifts in ocean currents can alter carbon deposits in ways that mimic industrial burning. Meteor showers leave scattered traces of exotic metals. Even lightning strikes can fuse soil into glassy fragments. The Earth is full of strange processes, many of which could fool us into seeing the hand of intelligence where there is none. But this does not mean the Silurian hypothesis is meaningless. Quite the opposite. Its very power lies in the way it forces us to test every anomaly, to ask not just what happened, but what else could it mean. Consider plastics. If geologists millions of years from now found tiny synthetic polymers in rocks, they might puzzle over their origin. Perhaps they would assume some rare chemical process in ancient oceans. But the Silurian hypothesis reminds us to keep a wider perspective. Sometimes the simplest answer is natural, but sometimes it is not. The same applies to radioisotopes. Natural fission reactors, like the one discovered at Oklo in Gabon, Africa, can mimic the byproducts of nuclear technology. But the fact that we know natural processes can create such signatures doesn't erase the possibility that technological ones could as well. And so the debate circles around two poles: the extraordinary possibility of ancient intelligence and the extraordinary power of natural Earth. One asks us to dream of civilizations older than humanity. The other reminds us of a planet capable of producing wonders and disasters without help from any mind at all. Science demands that we explore both, weighing the evidence carefully, resisting the lure of easy answers. This is where the Silurian hypothesis becomes less about proving ancient civilizations and more about refining our own understanding of Earth. By treating every anomaly as a potential technosignature, we test our assumptions. We build sharper tools. We expand our knowledge of volcanism, of impacts, of microbial revolutions, of the cycles that make and unmake worlds. Whether or not an ancient civilization truly existed, the hunt for one makes us better scientists, more careful readers of the planet's history. And perhaps that is the point. Perhaps the Earth's great story is already strange enough, already alien enough, without inventing lost civilizations to explain it. Perhaps the real lesson is that intelligence, whether it arises once or many times, always leaves a mark, and that the Earth, in its endless creativity, will always keep us guessing. The Silurian hypothesis may be about imagined civilizations buried in deep time, but its most unsettling lesson is not about them. It is about us. When we ask whether Earth has hosted other intelligent species before, we are really asking what traces intelligence leaves behind, how long those traces endure, and whether we ourselves are destined to vanish into the same silence. Our civilization feels enormous. We dominate landscapes, reroute rivers, dig into the crust, release carbon by the billions of tons, scatter satellites into orbit, and send probes beyond the edge of the solar system. From our perspective, we are titans. Yet measured against the scale of geological time, we are a flicker. The first Homo sapiens walked the Earth less than 300,000 years ago. Our cities are barely 10,000 years old. Our fossil fuels, the engines of modern industry, may last only a few more centuries at current rates of use. If we vanish tomorrow, in 1,000,000 years, most of our monuments would be gone. In 10 million, our cities would be buried, our metals corroded, our books and digital archives reduced to dust. Only the most stubborn chemical traces, the plastics, the isotopes, the scars in the carbon cycle might whisper our existence. This realization is humbling. It tells us that dominance is not permanence. If there were other civilizations, their time was short, their memory erased. If there were none, it may be because intelligence itself is fragile, rising rarely and vanishing quickly. Either way, the question becomes urgent. What will happen to us? Will we, too, be just another thin layer in the rocks? Climate change sharpens this question. When we examine past anomalies, like the Paleocene-Eocene thermal maximum, we see a world heated by greenhouse gases, oceans acidifying, species struggling to survive. It took the Earth more than 100,000 years to stabilize. Today, we are creating similar conditions in centuries. If an earlier civilization once triggered such a crisis, they may not have survived it. Are we walking the same path? rushing toward a cliff we cannot yet see? Mass extinction is another sobering parallel. Earth's history is marked by 5 great extinctions, each erasing the majority of life and reshaping the planet's future. Many of these were caused by natural disasters, volcanoes, asteroids, runaway climate shifts. But today, we are the asteroid. Our industries, our deforestation, our fishing fleets, our carbon emissions are driving species to extinction at rates unseen in millions of years. If a future geologist were to study our time, they would see a great dying. If another civilization did the same in their own age, we might never know. Extinction erases both the weak and the wise. But the Silurian Hypothesis offers more than warnings. It also offers perspective. By asking what traces we leave behind, we learn to see ourselves as part of the Earth's story, not above it. We see that the Earth does not remember in monuments but in chemistry. Our skyscrapers may not endure, but our plastics will. Our nuclear waste will. Our carbon will. When we imagine another civilization's traces, we are imagining what our own will look like. And perhaps this is the deepest implication. We are writing our obituary in stone right now. Every barrel of oil burned, every reactor split, every acre of rainforest cleared becomes part of that geological story. The Earth will carry our mark, whether or not anyone is left to read it. There is also a strange comfort in this. Civilizations may rise and fall, but life endures. After every extinction, the Earth blooms again. New species evolve, new ecologies form, new possibilities open. Even if we do not endure forever, we are part of that vast cycle. Perhaps intelligence will rise again in 1 million or 10 million years among creatures we cannot imagine. Perhaps they, too, will wonder if they were first. And perhaps they, too, will find the traces we leave behind and draw their own conclusions. Yet this raises a choice. Knowing that civilizations can be fragile, knowing that time erases nearly all, do we resign ourselves to disappearance? Or do we fight for endurance? If we are the first civilization, perhaps we are also the only chance intelligence has on this world. If we fail, there may not be another. The Silurian Hypothesis, in this light, is not just speculation but responsibility. It tells us that survival is not guaranteed, that our presence in the universe is rare and precious, and that the future depends on how we act in the present. We must also consider what traces we want to leave. Right now, our legacy is one of pollution, warming, and extinction. But could it be otherwise? Could we build a civilization that leaves behind not scars but harmonies? An Anthropocene marked not by collapse but by wisdom? That is the challenge before us. To learn from the Earth's past, whether or not it ever held other civilizations, and to choose a path that avoids their fate. The Silurian Hypothesis asks us to look back millions of years, but its real power is in how it makes us look forward. If intelligence is rare, then we are stewards of something cosmic. If civilizations vanish quickly, then ours must learn how to endure. The rocks will remember us, but the question is whether anyone else will. Will we be only a mystery in stone, or a species that learned to outlast its own fragility? The answer lies not in the past but in the choices we make now. Deep beneath our feet, the Earth holds a memory. It is a memory not written in books or carved into monuments, but pressed into stone, sealed into ice, scattered in the chemistry of oceans and skies. For billions of years, this planet has been writing its own story, layer upon layer, event upon event. Volcanoes, impacts, extinctions, births, and blooms. All of it captured, all of it recorded. And yet, in that great geological library, one question remains unanswered. Are we the first to walk this path, or merely the latest chapter in a story far older than we imagine? The Silurian hypothesis does not give us proof. It offers us a mirror. By asking whether there might have been civilizations before us, it forces us to confront how fragile our own truly is. We like to think of ourselves as permanent, as inevitable as the culmination of evolution. But the rocks remind us otherwise. 99% of species that have ever lived are gone. Entire ecosystems have vanished, leaving only faint impressions in stone. Civilizations, if they arose before us, would likely have fallen the same way, leaving behind only chemistry, only scars, only mysteries that scientists millions of years later might puzzle over. Perhaps we are alone in our history. Perhaps Earth has seen no other intelligence before us. If so, the silence of the rocks is not comfort but weight. It means we are the first. It means we carry the responsibility not only of our own survival but of the entire legacy of thought, of reason, of imagination on this planet. If we fail, intelligence may never rise again. But perhaps we are not the first. Perhaps in some forgotten epoch, life took a different turn. Perhaps creatures we cannot picture, reptilian architects, amphibian philosophers, insect engineers, built worlds and watched them crumble. If so, then their absence is also a message. It tells us that intelligence does not guarantee survival, that progress does not guarantee permanence, that even the brightest civilizations can be swept away by catastrophe or undone by their own hand. And so we stand in the present, looking both backward and forward. Behind us lies a vast and silent prehistory, stretching into billions of years, marked by mystery and erasure. Ahead of us lies an uncertain future, where our fate will be written not by inevitability but by choice. We may vanish, becoming only a faint chemical anomaly in the rocks. Or we may endure, carving out a legacy that stretches far beyond the lifespan of mountains and seas. The Silurian hypothesis asks us to hold both possibilities in our minds at once, to recognize that we may be unique, or we may be repeating an ancient cycle, to accept that either way the responsibility is the same. We must care for the fragile world that birthed us. We must learn how to live not just for decades or centuries, but for millennia. And we must leave behind traces not only of our power, but of our wisdom. One day, millions of years from now, perhaps another intelligence will rise. They will dig into the rocks and find our lair. They will see the carbon, the plastics, the radioisotopes, the extinction we triggered. They will wonder what we were like. And maybe, just maybe, they will ask the same question we do now. Were they the first or just the latest? The Earth will not answer, keeps its secrets well. But in the silence of its stone, we can hear an echo, a reminder that civilizations are brief, that time is vast, and that the only way to endure is to choose a future worthy of being remembered. And that is the legacy of the Silurian hypothesis. Not proof of lost civilizations, but a challenge to the living, a challenge to us,